Hey guys, Mrs. Dan's here. So we're on our last unit. We're going back to sequences. Now, when we've done sequences in the past, we learned that there's arithmetic sequences and geometric sequences. And the form in which we looked at our sequence was called an explicit formula. There's another way of representing sequences, and it's recursively. So we're going to talk about a recursive formula for sequences. So our objective is that we're going to learn that a recursive formula relies on knowing the previous term. We'll learn that recursive sequences involve a repeated application of a rule. And we're going to list the terms in a sequence that defines it recursively. And you have a do now that you could try on your own. I'll go over the do now and the development with you, and we'll even do a few problems from the homework, so you'll only have a little bit to finish up once this video is over. After the video, you should be able to tell me what a recursive formula is, and you should be able to tell me what we actually see in the formula that tells us it's defined recursively as opposed to explicitly. So just a reminder that a sequence really is an ordered list of numbers. You actually started looking at sequences when you were in like elementary school. They'd give you like a basic series, a list of numbers, and you'd have to decide what the next number was, right? Like if I gave you 2, 4, 6, do you know what the next one is? Of course you do. It's 8. Okay, so that's all a sequence is. It really is something very basic, but it's the notation that we use now that we're in algebra that is something new for you. This sequence, when you figured out that this missing number was an 8, you actually did it recursively. I'm sure you didn't know what you were doing was a recursive procedure, but hopefully you noticed that you added on 2 and you added on 2, so you decided to add on 2 again. You learned what this 8 was based off of what was given to you before. So hopefully I've just eased your mind about you actually already knowing how to do this. It's the notation that you're going to have to work on. So remember that each number in a sequence is called a term, and terms can be referred to in subscripted form. Remember that a sub 1, a sub 2, a sub 3, and so on. So the first term is a 1, the second term is a 5, the third term is a 9, and hopefully you're already deciding what's happening. Can you see that we are adding on 4 each time? So if I add on another 4, I'd find the next number in the sequence. So number 1, if n equals 4, what is n plus 1? Wouldn't that be a 5? If n is 4, what is n minus 1? Wouldn't that be a 3? So they can ask me what a sub 4 is, and I'd say 13. But then if they ask me what is a sub n plus 1, where we already know that n is 4, they're really asking me for a sub 5. Another way that you can think about it is if I know we're referring to a sub 4, and they're asking for a sub n minus n plus 1, it's the one after 4. So that would have to be 17. If they ask me for a sub n minus 1, remember n was a 4, so they're really asking me for the third term. This is a 9. So this is the kind of notation that we're going to see in recursive, talking about the term that comes after and the term that comes before. So recursion really is a process of choosing a starting term and then repeating from there. You keep on applying the same process each time. So I'm missing a line here. If I'm given a sub 5 and they're asking me what the term before it is, that's an a sub 4. If they want the term after it, it's a sub 6. Right? This seems like common sense, doesn't it? So if they're talking about a sub n, the one before it would have to be a sub n minus 1, right? It has to be 1 less than it. And if they're talking about the one after it, it's a sub n plus 1. This is what we're referring to when it comes to recursion. Recursive formula. We're going to see this n plus 1, and n minus 1. And please know that a sub n is some term. A sub n plus 1 is the one that comes after it, and a sub n minus 1 is the one that comes before it. And if you understand that, you're good. So if I continue here, the one that comes after a sub n plus 1 must be an a sub n plus 2. And the one that comes before a sub n plus 1 must just be the a sub n. If we're talking about in function notation, f of 6, the one before is f of 5, and the one after is f of 7. The one before f of n is f of n minus 1, and the one after it is f of n plus 1. And if they give me f of n plus 1, then the one before it is just the f of n, and the one after it is now an f of n plus 2. Something that comes one after is just one, you just add on one more. Something that's one before, you take away one. So in a recursive formula, each term is defined as a function of its preceding term. So what that means is that I need some kind of starting value, and then I need something to follow. So there's always two parts. This is something that you have to refer back to always. A recursive formula has two parts: a place you start, and then a formula that tells you what to do. So all of this is about an arithmetic sequence. Remember, with arithmetic sequences, it means that we're adding on the same number. It's the same sequence, just written multiple ways. They're all recursive. This is the starting value, and then this tells me what to do. So I start with a 4. And now this is where things are like a little confusing to some people. I'm going to teach it to you the way that I think about it. The way I think about it is when I see this funky stuff on both sides, I know I'm given a recursive formula. Also, what I know is I need a starting value, and I need to know what to do. So this that I just put in a box is representing a value I know. This tells me what to do. This tells me add on 2 each time. So what I know is a 4, and then I add on 2, so my next number is a 6. Now I know the 6, so now the 6 takes the place of this box. I know a 6, and I add on 2, so I get an 8. Now I know an 8, and I add on 2, so I get a 10. So you have a starting value, and then you have what to do. You don't necessarily have to keep on plugging in. As long as you know what to do each time, just keep on doing it. And this is just written in a slightly different notation, but it says the same exact thing. This is what I start with. This is what I know, which is the 4, and this is what you do. So it's really representing the same exact thing. I start with a 4. What do? You add on 2. What do I do to what I know? I add on 2. What do I do to what I know? I add on 2. So this is key, and this is key. This is what you start with. This is what you do. That's how I look at it. I don't let all this crazy junk here mess with my brain. This is what I start with, and this is what I do. I start with a 4, I add on 2, and I keep on doing it because it's recursive, so you keep on doing it. So I don't really have to keep on filling this all in. This tells me what I start with. This tells me what I do. So I'm going to add on 2, add on 2, add on 2. Keeps on telling me if I'm the first 5 terms, and I only did 4, but you know what the next one is. Okay, so no matter which notation they use, find what to start with and find what to do. That's all I want you to do. So we're not even doing this part today. We'll do that in tomorrow's lesson, so don't even worry about it. Let's go on to example 3. Geometric, remember, means that we're multiplying by a number. So here we go. This makes sense to me. This is what you start with. So maybe you should write it down right away. And then this tells me what to do to what I already know. This funky notation is what you know. This tells me what to do. Since the 2 is right next to it, remember it's assumed multiplication. So it's telling me to multiply each time. Multiply by 2. I know a 4. If I multiply it by 2, I get an 8. Now I know an 8. If I multiply it by 2, I get a 16. Now I know a 16. If I multiply it by 2, I get 32. Now I know a 32. If I multiply it by 2, I get a 64. And that's what all of this says, just slightly different. This is what you start with. This is what you know, which in this case is a 4 to begin with, and this is what you do. So I know a 4, and I know I'm supposed to keep on multiplying what I know by 2. And all of these tell me the same thing, okay? This is what you know. This is what you do. This is what you know. This is what you do. And we're not going to worry about example 4. So let's take a look at number 5. Sometimes sequences, although there's a pattern, it's neither arithmetic nor geometric. Remember, arithmetic means add the same number. Geometric means multiply by the same number. With an arithmetic sequence, I just want to remind you, we say that there's a common difference, and we use D to represent it. And with a geometric sequence, we call it a common ratio. And we use R to represent it. This is the number that you keep on multiplying by, while this D would be the number you keep on adding by. So this is a famous sequence. It is neither arithmetic nor geometric, but what is the pattern? Take a look before I tell you. So I don't know if you found it, but if I add these two terms, I get the next one. Now I'm going to erase what I just wrote, because now if I add these two terms, I get the next one. And then if I add these two terms, I get the next one. These two terms, I get the next one. These two terms, I get the next one. So you're adding the two terms before it to get the next one. So let's write that down. Add the two previous terms to get the next one. And if you're not sure what that means, like the 0 plus 1 gave me a 1, and then the 1 plus 1 gave me the 2, and then the 1 plus 2 gave me the 3, and so on. So to write this formula recursively, they had to give me two things so that I could say add those two things. I needed to know those two things first. So now summary. First determine what the first term is, and then determine what's being done to that term. That's it. So I'm going to do some of this with you, and then you'll finish on your own. So on number 1, remember there's always two parts. The given term, so right here, f of 1 is 6. I know my first term is 6. I need to list the first 4 terms. So there's 1, 2, 3, 4. I put dashes sometimes to keep my thoughts in order. I know I have to fill in these blanks. So when you have funky notation on both sides, one of the sides tells you what to do. This is what I do. There was a dot there, so I'm going to multiply by 3. Don't let this bother you. This is just what you know. Whatever you know, you multiply by 3. I know a 6. If I multiply it by 3, I get 18. Now I know 18. If I multiply it by 3, I get 54. Now I know 54. If I multiply it by 3, I get 162. When you figure out that it's recursive, meaning that there's two parts, right? Here's one part, and here's the other part. One part tells you what to start with. So if you have a calculator, just type it in. That's what I'm starting with. And then look at the part that tells you what to do, and just notice this, the multiply by 3. Right on your calculator, just hit times by 3, enter. And then keep on doing it. Times by 3, enter. Times by 3, enter. Recursive builds on what you know. You have to know the thing before it in order to get the next one. It's actually not the best form of an equation. We like explicit formula better, which is what we did in the past, because I could find any term number. When this is defined recursively, like number 1, if I asked you what's the 100th term, you would have to keep on doing this process 100 times. Okay, you can't get to it quickly. You have to go through it 100 times to get to that 100th term. Let's do number 3. Take a look. This is the funky stuff. This is what I know. Good. I know to start with a 6. This is what I do. Divide by 3. This is what I know. I don't care what kind of crazy form it's in. I know that's a 6, and then I divide by 3. So I get a 2. Now I know this is a 2 that I divide by 3. I'm just going to write it as 2/3, right? 2 divided by 3, I can write it as just a fraction. Now I know the 2/3 that I have to divide by 3, so now that's a 2/9. If for some reason, like we wanted to talk about a 0 term, that's when you like back it up, right? We've talked about 0 terms in the past. They're not asking me to find the 0 term, so you don't have to. But do you realize that the 0 term would be an 18, right, in order to keep this pattern? Because 18 divided by 3 is 6. I'm not going to write it down. They didn't ask me for the 0 term, but I'm just pointing out that you can find it if necessary. So with a recursive formula, find the number you know. That's your first thing. Then decide what to do. So by looking at this, what do you know? Oh, I know my first term is an 11. This tells me what to do. Just keep on adding on 6. So I get 17, and then I get 23, and then I get 29. Not a big deal. Don't let the notation panic you. This is not a big deal. It's what you know, and then do something to it each time. Let's take a look at number 7. What do I know? Yep, you're right, 50. What do I do to it each time? Absolutely. Divide by 2. So if I divide this by 2, I get 25. If I divide this by 2, I get 12.5. Or I could have written it as 25 over 2. Or you could even pull out that calculator, like I said, put the first term in, and then keep on typing in what it says. Divide by 2, second term. Divide by 2, third term. Divide by 2, fourth term. Okay, it's not so hard. It's just that crazy notation. Too bad they don't give it to you in words, right? Too bad they don't say, oh, your first term is 50 and I want you to keep on dividing by 2. You'd say, okay, that's really what this all says. They just didn't want to type out all of those words. So what do you know? Yes, you know 1. What do they want you to do? They want you to multiply by -2 and add on 8. So just follow your order of operations. You always multiply before you add. So multiply by -2, then add on 8. Not a big deal. So I know the 1. If I multiply it by a -2, I have -2. If I add on 8, I get 6. I just kept track of it a little bit in my own brain. Now I know 6. I have to first multiply it by 2, so I get -12. Then I have to add on 8, and I get -4. Now I know -4 has to get multiplied by the -2, which is a +8. And then I have to add on 8, so I get 16. And that's the first 4 terms. So it comes down to looking at your equations very carefully and deciding what to start with and then what to do. That's how I want you to think about it. What do I start with? And then what do I do? We're going to do number 11. It has 2 stars next to it because it's the trickiest one of them all. And I've seen some tricky stuff like this on a Regents exam, but usually it's the more basic ones that we've done. So, I know to start with a 4. I know I'm supposed to be finding the first 4 terms. But what do I do? This is tricky, right? This is like what I know, and then this is what I do. So what the heck is n? Remember, this is the first term, so n is 1 here. This is the second term, so n is 2. This is the third term, so n is 3. And this is the fourth term, so n is 4. This is what I know, and I want to get the next term. So to what I know, I need to add on this 2. This 2 is what I'm adding on. Now I know 6. I have to add on this 3. Now I know 9. I have to add on this 4. And this is a little tricky. Okay, this is the previous term, right? The n minus 1. It was this 4. This n is the one that comes after it, so that's why I had to add on the 2. This is what can just be a little bit tricky. I wasn't going to do another one with you, but I want to see if there is another one I should do. Yeah, I should do 19 with you. Because some people think 11 and 19 are the same. I would say they're similar but not the same. I just want to point out here. Do you notice this is what I knew? It was f of n minus 1, and I needed to add on an n. I needed to add on the term number that came after the thing I knew. On this one, this is what I know, and this is what I'm subtracting away. I'm subtracting away the term number of the thing that I know, because this is an n, and this is an n. So what I know, I'm subtracting away its own term number. So I'm going to write down what I know. I'm going to write down that this is when n is 1, this is when n is 2, this is when n is 3, and this is when n is 4. This is what I know. This is this term number. So what I know, I'm now subtracting away the term number here. And these are the 2 that are tricky. So this turns out to be a -3. Now I know a -3. I'm subtracting away this, though. So I'm going to subtract away a 2. And now this is a -5. I'm going to subtract away this. So I get a -8. There is a way of doing it by substitution. It's not my preferred way. So I just want to reiterate what I did on 11 and 19. I noticed the term that I knew had an n minus 1, and I noticed what I was adding on was an n. It's the term number that comes after what I know. That's why I use the one after. On this one, what I know is an n, and what I'm subtracting away is also an n. So I use the term number of the thing that I knew already instead of going after. That's how I do it. Some people do it as a substitution way. Let's see. If f of 1 is 4, this is a 4. The thing that comes after it, this is when n is 1, so what comes after it is n is 2. I don't know. It's still like the way that I'm thinking about it. I want to add on the 2. Over here, this is my a sub 1, and that's an n, which means this n that I'm using is a 1. So you can see that in this case, I was using when n was 1, where in this case, I was using when n was 2. Because this is an n minus 1, and this is an n. It goes back to what we did on the very first page. Where if this is an n minus 1, the one before it is an n, right? It's something along those lines. If this is an n, the one before it is an n minus 1. The one after it is your n plus 1. I'm going to find some other links that I can send you in case that makes things a little easier. Remember that you can easily do number 1, 3, 5, 7, and 10. Those weren't so bad. Those told you exactly what to do. The ones that are a bit tricky is when they use an n to tell you what to do. And that's that. So good luck. Please send me questions. And please look at the additional links that I'm going to provide. Okay, see you soon. Bye.